Well, ever since I was a kid, I've always been fascinated at how we are able to build buildings, bridges that span distances which are beyond your imagination. How engineers defy gravity to build very, very tall structures. I've always been amazed with that, and I thought that was something which I want to look into deeply. And when I entered the Faculty of Engineering, I did a bit of research, and I thought this is the field I want to go in because I thought this is the kind of area that I'd be interested in. I've always been encouraged to follow my path, my interests, and I've always been interested in how engineers have been able to build these magnificent structures, bridges, monuments, and as I say, defying gravity, and to build it stop. That interest has always remained with me all my life, and that is why I chose a career in civil and environmental engineering. Well, after I graduated, I started working as a structural engineer in a multinational company here in Singapore. I was fortunate to essentially develop a mentor-mentee relationship with my chief engineer then, Mr. Nasim Shazad. And with his mentorship, I was able to hone my skills. I became a better engineer because he also stretched me and gave me many opportunities. I thought that was a moment where I realized that this is the kind of things that I want to do. And with his guidance, I was able to become a better structural engineer. So those are the kinds of moments that you reflect back, that you meet somebody who's actually a giant in himself, being a chief engineer of a multinational company, and he was able to take me under his wings, give me the guidance that I needed, but at the same time I was able to fly with the extra wings that he gave me, and I was doing quite well in the company then. So I would remember that as one of the memorable moments in my life as a practicing structural engineer. You know, I met many great lecturers, but there was one lecturer that will leave an impression in your life, which is the late Professor Lee Seng Lip. He taught very few classes, but the classes he taught were basically on structural analysis, and it was a joy to attend his class. The material is not that difficult to understand, but he made it interesting and exciting because of his illustrious career. You know, he was from Berkeley, he went to Northwestern, came back to this part of the world and became our head of department. So he didn't teach a lot, but when he taught those classes, I was always looking forward to it because I know when I attend his classes, I will learn something new, something different, something other lecturers couldn't have done because they don't have that kind of background and wealth of experience he did. So I've always remembered his classes. I enjoyed it. For the record, I aced all his classes. But most importantly, I think the lasting impression that he's left to me, how to be a very good structural analysis, how do you define the problem, how you analyze it. It was very, very interesting for me. I always remember that. I'm grateful for the opportunity because, you know, not many people have learned from somebody like Professor Lee Seng Lip, but I thought that experience for me was very memorable and it has remained etched in my memory for a very, very long time. I can recall two experiences which comes to mind. One interesting, one not so interesting, but they have their own value in itself. I was part of the team that was responsible for designing the OUB Center. Now it's called UOB, right? It's a very big building, you know, massive structure, and our Melbourne office was also taking the lead, but the Singapore office was part of that team. So I remember one particular discussion we had with my chief engineer, the architects, and the owners. The architect then, Kenzo Tange, the great Japanese architect, and part of the building was to have these columns which was 5-story tall, no braces, no nothing, right? So as a structural engineer, you worry about buckling load because it's taking so much of the load from the top. There was a great discussion in the room, banging of tables, and Mr. Nasim was insisting, you must put braces because if not, this thing will buckle. I can't recall how it ended, but I can recall the heat and the discussion at that moment, you know. And lo and behold, we finally got the project rolling. And 2 weeks before I left for my postgraduate studies, I was assigned to supervise the concreting of the rough basement in the building, you know. So there I was in the middle of the night, 3 a.m. in the morning, because you do concreting at night, and you just have to make sure that everything goes according to what we have planned for, basically. So in a way, that was a project I associated very, very closely. The other thing, of course, that came out from that project was that when we were designing the basement, it was beside the MRT tunnel. And they have to make sure that the the thing stay, it doesn't move and so on and so forth. So we have to put in measurements and what have you, basically. MRT tunnel was being constructed. We were building the building, basically. So it was a massive project that really opened up my eyes about how engineering can solve some of the most difficult and delicate problems. The second project is a bit more sad for me. I was assigned to this project to design an apartment building in Orchard Road. The interesting thing about that design was that the floor plate looks like a butterfly. We call it the butterfly building, And the architects and the owner doesn't want any beams. So it's a flat plate and resting on columns. So you worry about the punching load and so on and so forth. So that was my first time designing floor plates of that size, right? So I have to do my own analysis. No computers at that time. You cannot do finite element analysis because you don't have the program. But we did it. We were so proud of the design. But it was never built because we only decided to ditch the project. So I can't point to the building and say, I did the structural design, right? But it's one of those memorable moments because you make that leap for the first time in your life to do something very different. I'm grateful for the opportunity when I did my stint as a structural engineer at that company, and I was given that trust to design that building, of course, together with the chief engineer. So those are the two memorable moments of my life as a practicing engineer. It's an interesting question. When I reflected on it, I think the thing that we cannot ignore is the biggest elephant in the room, which is digital technology. It is emerging very rapidly. It is shaping many, many disciplines from accounting to medicine to engineering. I think that is a trend that we need to watch. But the more important trend for me is that how will that shape the engineering profession and the outlook of the engineers themselves. Technology is a tool. It cannot solve the problem. Engineers are the one who solve the problems. It is how you understand the problem, define the problem, and see how the technology is being used. Take, for example, you're trying to design a foundation for a building. You need to know the geotechnical properties of the soil. You need to know whether it can carry this type of load or that type of load. The machine may be to tell you, but you as the engineer to understand the fundamentals, load bearing, skin friction. Then you decide, after you have defined the problem, what sort of technological tools that are needed for this particular project. So my feel is always that it's great to have these tools, but they're only tools. Ultimately, it is the engineer who has to make the decision. So I hope engineers of the future continue to build on new tools, but never abandon the fundamentals of engineering. The basics of engineering will put you in good state for the rest of your life. You cannot run away from basic mechanics and everything that you have learned, because those are the things that put you on a good foundation. Without that foundation, you cannot use the tools, right? If you're using the tools mainly for using it, then you're actually on the wrong path. But if you understand the fundamentals of the problem, what is needed, then when you look for the tools, you look with the tools, your eyes open, and a keen awareness that those tools can only help you to design the building better rather than the other way around. I've always believed that engineers are problem solvers. We are designed not to, sort of specific discipline of either electrical, mechanical, or civil, but we're supposed to solve problems. There are problems in human society. Look back in history, all the great monuments that we have built were built by engineers who are trying to solve a particular problem, right? So I think that's very important. But we are facing great challenges, from climate change to energy security to food security. I would like to see the engineers of the future getting involved in this sort of problem, finding solutions to this sort of problem. Why? Because it's existential. If we can solve this problem, we can at least have a good chance to ensure that the human race will continue. Engineers are good at solving problems, but these problems that we are facing are complex. They require a collaborative approach. So engineers should be able to work with people from other disciplines to bring their minds together, bring their minds to bear upon this problem to find solutions for mankind. Climate change is a very, very big problem. Energy security, energy transition is a big problem. Food security is a big problem. These are problems that lend itself to problem-solving skills. But I think we need to have a collaborative approach, and I hope our future engineers realize that they need to work in a team, not alone. Work together with the right skill set, the right group of people. I think we can then bring out some solution for us to consider. So I really hope that the next generation put their minds to solve some of these major existential problems, not because they are sexy or seductive, but because it is about our survival as a human race. We need to put our best minds, and we have some of the best minds in engineering, on this side of problem, because I think that's how we can guarantee a future for human civilization. If I were to meet a parent today of a young child who is about to decide which discipline he would like to go in, first I'll convince the parent that engineering is the place to go. Why? Because engineering gives you a skill set that will last you for life. It gives you the ability to solve problems, to understand problems deeper and find solutions. The next level, I will encourage you to consider civil and environmental engineering. Why? Because as a discipline, it covers every aspect of human life, from the humble drain, to the roof, to the buildings, to the satellites. All of this requires civil engineering skills. So I think if you are trained in that field, you will have first a job for life, but more importantly, you have a role for life in building a better human society. That's what I would tell the parents of today about the profession that they should consider for their young children. Hi, on this special occasion, the 70th anniversary of the Civil and Environmental Engineering faculty here in NUS, may I extend my best wishes to the university, to the faculty, for many, many more good years. We have remained relevant for the last 70 years, and I think we'll continue to be relevant for the next 70, even 100 years. We can only do so by reinventing ourselves, by ensuring that the students that come to our halls are equipped with the best skills possible to go out and solve major problems that we are facing. All the best, and I'm confident that we can achieve our goal to be the place for all of young students who want to be. Thank you.